All right, so we're going to do inverse relations and functions. So the inverse. Okay, so a couple things with the inverse. You notice we have a square root equation here. And so first thing I want to do is I want to get a concept and an idea of what the graph of this looks like. Okay, so do you remember graphing form? And I hope you do, right? It's y equals square root of x minus h plus k. You could have an a out in front of that absolute value. But you can see from our function here that the h value is -3 and the k value is 1. So there's going to be a vertex at -3, 1. And that's what I have graphed here, right? There's the vertex. I've already graphed the rest of the function. Now, first off, is this in a one-to-one relationship? And it is, right? Remember, that's the horizontal line test. No matter what horizontal line you pick, does it only hit one point of the function? Yes, it only hits one point. Therefore, it passes the vertical line test, and therefore it has an inverse. It's in a one-to-one correspondence. Right, before we continue, let's figure out the domain. So the domain is x greater than or equal to -3. And let's figure out the range, the y values, and that's y greater than or equal to 1. Okay, so we got a domain and range off of our original function. Okay, how do you find an inverse? Well, if you remember, you swap the x's and y's. Put an x everywhere where there's a y, put a y everywhere where there's an x, and then solve for y. All right, so I got to move this positive 1 the other side by adding a -1 to both sides. Okay, and now I'm ready to square both sides, right? I've isolated the radical. And I better be careful, that's a 3 in there. All right, so I'm going to square both sides. Okay, on the left, when I square this, I get x squared minus 2x plus 1. And the right side ends up y plus 3. Okay, so again, I got to solve for y, so let's add a -3 to both sides. -2 equals y. And really, if I want to get this in a graphing form to show you the graph, then I'll have to do other. But to find the inverse, that's it. That's the inverse, right? F to the -1 of x equals x squared minus 2x minus 2. Don't forget at the end to write f to the -1 of x. Okay, so that would be the inverse. Now I want to show it to you visually, so I'm going to complete the square here and show you visually what ends up happening. All right, so real quick. X squared minus 2x minus 2 equals f to the -1 of x. Okay, remember, take the b value, that 2, divide it by 2, you get 1, square it, you get 1. If I edit 1 inside the function, I have to take away 1 outside of the function to keep it balanced. I got a perfect square here, right? Square root of the first, square root of the last, sine of the middle. -3 equals f to the -1 of x. Okay, there's graphing form. If you can tell, this is a parabola, right? It's a parabola. All right, so let's go ahead and graph it. What's the vertex? I can read h and k, right? The h value is 1. The k value is -3. By the way, notice that this is the inverse of the vertex of the original. Pretty cool, right? The x is the y and the y is the x. Okay, so let's graph this point. So 1, -3, and it's going to be right there. Okay, so xy chart. And let's do 2. 2 minus 1 is 1, 1 squared is 1, 1 minus 3 is a -2. So I get the point 2, -2. Now, you might say, Mr. Scarfi, this is a parabola, and so we got a line of symmetry, and therefore you have that point on the other side of the line of symmetry. Normally, yes, but remember, we're doing an inverse. And look, here's the situation, okay? The range of the original becomes the domain of the inverse. So we can only have values of x greater than or equal to 1. Pretty cool, huh? Okay, so let's finish this thing off. So let's do 3. 3, again, I'm subbing in right here, right? 3 minus 1 is 2. 2 squared is 4. 4 minus 3 is 1. I get the point 3, 1. And you know what? That's enough to show, because I know we have this point. Because remember, the inverse is mirrored about a 45-degree angle, and it would go just like this. And does that look like the mirror image? Of course it does, and it's the inverse. So inverse relations and